Dear students, in probability theory, you have seen events, you have seen sample space, you have come across mutually exclusive events, mutually inclusive events, exhaustive events, independent event, all that you have come across. And finally, we come to the concept of conditional probability, and those concepts also we are going to apply into this sum. In particularly exercise 12.3, the basic concept of probability, some values are given that 0.4, probability of A is 0.4, that is the event A probability value is 0.4. The event probability of A union B is 0.7. Only two things given. We wish to know what is the value of P of B. Remember that this is what we want to know. P of B we want to know. If A and B are mutually exclusive, that is the first question. And second question, A and B are independent. And probability of A given B, one result, probability of B given A, another result. In all the four cases, we wish to calculate P of B. Remember that. First one, A and B are mutually exclusive. What do you mean by mutually exclusive? One event do not influence of the other. So, one event happening, the other event is also happening. So, this event do not influence the other event. So, that means, so when the event when events occur, so definitely it doesn't going to affect the other one. When you take intersection for both, you will, both are different events, intersection definitely is equal to empty set. So, that is what mutually exclusive. So, you remember the concept of mutually exclusive. So, if at all the events are like this, so this is A, this is B, A and B, when I take intersection you will get this. That means probability given P of A is nothing but 0.4. P of A union B is 0.7. The first one, given that A and B are mutually exclusive, A and B are mutually exclusive. The sense P of A union B is equal to, whenever happen to notice union, it is nothing but plus P of B. That is what mutually exclusive events. Either A or B, that is P of A plus P of B. Here P of A union B, already the value is given, that is nothing but 0.7. P of A is how much? This is also given 0.4. That is P of B we wish to calculate. So, bring this value here, 0.7 minus 0.4, which is 0.3. That is what the first result which we have completed here for the first question. If two events are mutually exclusive, you must have the knowledge of what is A union B. Probability of A union B is P of A plus P of B. With the help of this identity, we have applied this. Those two results we know. So, the unknown thing we kept as it is. We found out the value of P of B. And second one, remember that A and B are independent. Since A and B are independent, notice that P of A intersection B is equal to P of A into P of B. Remember, this is the formula. If it is independent, you must understand this is the formula P of A into P of B, that is what independent. But the question is what we have, it is P of A union B here. So that means first of all we have to calculate what is P of A union B, then we can apply, we will get the result. P of A union B, what else here? P of A union B, A and B are independent events, P of A intersection B is equal to P of A into P of B. We know what is P of A union B. What is P of A union B? It is equal to 0.7, which is given. P of A union B, what result we have? We can apply addition theorem on probability, that is P of A, remember that, plus P of B minus P of A intersection B, which is equal to 0.7. That is what the thing, because P of A union B, only the result what we have, P of A union B, this is the one, P of A plus P of B minus P of A intersection B. You can apply P of A intersection B is this. So that means P of A plus P of B minus P of A into P of B equal to 0.7. What we want to calculate? P of B. So that means P of B 1 minus P of A 0.7. This P of A you bring it to other side, minus P of A here. That is 0.7 minus P of A is how much? We have only 0.4. That means 0.4. That means nothing but 0.3. 0.7 minus 0.4 is 0.3. P of B 1 minus P of A. P of A how much? It is 0.4. This is 0.6. 1 minus this is 0.6. P of B. Therefore, what is P of B here? Therefore, P of B is, what is on the right hand side? 0.3. What would be on the left hand side? Is a product, so you bring it down. Don't take this one on the right hand side minus or anything, because it's a product, you have to bring it down. 3 by 6, it is nothing but 1 by 2, which is 0.5. So P of B, what we have for the second one is 0.5. We have found out the second result. And third one is what? P of A given B. Dear students, we recall all the three fundamentals. One is mutually exclusive. Second one is that is independent events, and simultaneously you are just bringing the formula of addition theorem on probability here, and here conditional probability. This problem you are just getting all the fundamentals. So probability of A given B is probability of A intersection B by probability of B, which is equal to 0.4. This is the formula. Probability of A intersection B by probability of B is equal to this much. We can apply the formula. Addition theorem on probability we can apply elsewhere. What is the addition theorem on probability? P of A union B, P of A plus P of B minus P of A intersection B. You can bring this value to here, this will you can take it to this side. In that way also we can do. See, P of A given B is P of, by the conditional probability definition, P of A intersection B by P of B, which is equal to this. What is P of A intersection B? We can bring it this value over here. That means P of A, remember, plus P of B minus P of A union B over P of B is equal to 0.4. Okay. What is the unknown? P of B only. Remaining all values we know. P of A is how much? 0.4. P of A union B is 0.7. That's all. So 0.4 plus P of B minus 0.7 over P of B is equal to 0.4. Okay. 0.4 minus 0.7 is minus 0.3. So that means P of B minus 0.3 over P of B is equal to 0.4. Now you can do only the simplification part, only simple strategy, just apply, you will get the answer here. So what we can do, just cross multiply and bring in this value, or just you divide this part. P of B by P of B is 1 minus 0.3 by P of B is equal to 0.4. Just minimum some steps, A by C minus B by C, like that. So 1 minus 0.4, which is equal to 0.3 by P of B, which is 0.6, and here 0.3 over P of B. Cross multiplying, P of B is equal to 0.3 by 0.6, which is equal to 1 by 2, which is 0.5. That is for the second one. Third one, P of A given B is equal to 0.4, for which also we found out P of B. What about the fourth one? The same way we can analyze. Fourth one is P of B, probability of B given A is equal to 0.5. That is the final one. So the first one we have taken and the second one finished. This is the third one. Here also we can apply the same formula. P of A given A intersection B over P of A is equal to 0.5. Here P of A intersection B, we can apply the same formula like this. So what we can do, here it is not required this one, so we do that with the help of here. So P of A intersection B, once again we can apply P of A plus P of B minus P of A union B, addition theorem on probability, over P of A equal to 0.5. Dear students, what are the things you can do if P of A is 0.4, already you know. P of B we do not know. P of A union B, already we have the value that is given 0.7 over P of A 0.4, which is equal to 0.5. Okay. Just multiply, cross multiply. So P of B, this and this you makes minus negative 0.3 over 0.4 equal to 0.5. So what you have the value in this? 4, 5, 6, 20 is 0.20, that is nothing but P of B minus 0.3, that is nothing but 0.2. That is, that last 0 doesn't make difference. Okay, now this one. You take this minus 0.3 to other side. P of B is equal to 0.2 plus 0.3, which is equal to 0.5. So in this way we found out the result of P of B. So in all the 4 cases, first one we noticed mutually exclusive, P of A plus A union B is equal to P of A plus P of B. Independent events, P of A intersection B, P of A into P of B, with the help of that. Next one, conditional probability, P of A given B, we applied. Addition theorem, once again we are using. And P of B given A also, same addition probability, and then addition theorem, we found out the result. All the cases we have found out, in every cases we found out only the result P of B.